Dear students, today we are going to discuss about representation of Q using linked list in Unit 3 of Data Structure through C. Before going to start the presentation, we must be discuss about course learning outcome, that is course outcome CO. After completion of this presentation, students will be able to represent Q using linked list. So today we are going to discuss about how to represent the Q using linked list. Already we have discussed about Q using array. So we know Q is a FIFO data structure, like first in first out. Which element is entered in the queue, that will be taken out first. The element in a queue are added at one end called rear position and removed from other end called front position. So in the queue, how two pointer, one pointer called like front pointer, then another pointer is called like rear pointer. We can insert any element in the queue. We can use rear pointer. If you want to use delete operation, we can delete element from the front pointer. So we already know queue may be implemented using either array or linked list. So this is a symbol structure, diagrammatic representation of queue. The first queue is represented with array 0 to 9, that is array of 10 size. We have created the memory, and then for 6 elements we are already stored. If we want to add any extra element, the rear position we can add it. The rear is 5 already. Then we can add in the rear plus 1 position. So we can use the rear pointer for insertion. But if you want to delete, means we can use front portion. So the front portion already stored in 12 because front pointer is pointing to first node of the queue. This is a simple queue operations. What is linked queue? So linked queue means, so we know linked list. In the linked list, the elements have, so elements will be called like nodes. The node have two portion. First portion have the data, second portion have the pointer to the next node. So the linked list have start pointer is pointing to the first node of the linked list, null pointer is pointing to the last node of linked list. The intermediate nodes have the pointer to pointing the next element in the linked list. So how we can implement queue in the linked list? So start pointer is there, null pointer is there. But we know queue how front pointer is there, rear pointer is there. So simply we can assign start pointer for the front portion, null pointer for the rear portion. But in linked list, we can add both front or front portion or intermediate portion or last portion. But here we can perform insertion operation in the rear portion only. And then we can perform delete operation only in the front side. That is the difference between linked list and linked queue. So here, in case we want to insert any element, first we have to check some elements already available are present in the queue or not. How we can check it? So we can check using this condition, like front equal to rear equal to null. So front equal to rear equal to null means there is no element, so queue is empty. We cannot perform any operations. Like we can insert, but we cannot delete because queue is empty. It will comes under underflow condition. So now we can discuss about insert and delete operation. Insert operation, how we can perform. So now we will perform the insert operation. First, before starting the insert operation, we will check the front portion is null or not. If it is null, we can create new node. That node only available in the queue. There is no element. So if it is not null, we can add this new element to the previously available elements. So now I will give value 9 for insert new element. So before that, it will check the condition friend equal to null. If condition holds, then the queue is empty. It will print friend and rear equal to same new node only. So we allocate memory for a new node, store the value in the data part and null in the next part. So like this. When we are creating the new node using linked list, the node have two portion. First portion have the data, second portion have the null. Clear? So if in case friend equal to null means queue is empty, this node only available there. So we can give null pointer here itself. But both front and rear will pointing the same node. Okay, because there is no more node in the queue. In case some nodes are there, we want to add this node there, what we have to do? So we can add in the rear position only. So we will write the algorithm for that. First we will create the memory for new node and name it as PTR. PTR means pointer. So the PTR is called a new node. Okay. So PTR have two portion. First portion is data portion. Second portion is next portion. Next pointer. So the first portion PTR, first portion data have stored the value of given value. So for this example, I given 9 that will be stored here. Then I will check second portion is next, that is pointer. The pointer will pointing to next node or this is the last node that we have to finalize. For that we are checking friend equal to null. In case already front pointer is null means there is no node in the queue. So this is the only one node. So what we will do, both front and rear will be pointing to the same pointer. Clear? So front of next and rear of next will be pointing to the null pointer. Clear what I am telling? So both will be represent the single node. In case already some nodes are there means the PTR new node will assign to rear of next node. So here rear is there. We are creating new node like this. So we can assign this pointer is pointing to new node. So that only we are doing here. PTR is the new memory location created for the new node. That pointer will be assigned to rear of next. Rear of next, that means this portion assigned like that. So then the PTR will be converted to rear. So already this is the rear. Then we are added this node. So this node will be converted to rear. So that's why order like this. Then finally the rear of next will be null. So that we are did here. This is the insertion operation. Delete operation. How we can perform delete operation? So we can delete using the front pointer. First we have to check friend equal to null or not. If it is null, we cannot delete any element because the queue is empty. So if it is not null, we can remove the front portion, then friend will be assigned to friend of next. Okay, for this algorithm will represent delete operation of linked queue. So here first we have to check friend equal to null. That means there is no element, we can print underflow operations. So in case it's not null means some elements are there. So friend will be assigned to new pointer. We can create the temporary pointer. So then friend of next will be assigned to front portion. Then we can free the PTR. Clear? So now we can write the program for linked queue. So we will perform two operations. One is insert operation, another one is delete operation. Here Q insert operation called like NQ, delete operation called like DQ. So here I given the choices for choosing the user. Then it will get the choice from the user, then it will be performed. The first choice for insert, second choice for delete, third choice for display. The first choice if I given, it will be insert operation. So how we can insert, I already told. We can create the new node here. So for this new node, we can create the memory location. So for that size of structure of node, the two portion will be created. So the first portion called data, second portion called next. New node of data is the first portion. New node of next is the second portion. The first portion how the value, which value we are given, that will be assigned. And then here the null pointer is assigned for next pointer. Initially we have created one node. Then we have to check the front portion is null. That means there is no node available in the queue. So because the new node will be assigned as both front and rear, because here only one node is there in case front equal to null. If else means some other nodes are there, then what we have to do, we can add the new node in the rear position. So rear of next pointer will be changed to new node, and the new node is assigned as a rear position. So then insertion is successfully printed. Delete operation. How we can perform the delete operation? First we have to check front equal to null. So that means Q is empty will be printed. This is a common. So in case front not equal to null means, so some node is there. Then initially front node will be assigned as a temporary pointer, and then front of next will be assigned to front, because front node is there, front of next node is there. So now the front will be pointed to next node, because front node will be removed from the queue. So front of next will be assigned to front. So which element is removed? That is front portion of data element we are removed. So that will be stored as the temporary pointer. Temporary of data will be removed. That will be printed here. Then we can remove the temp for using free operations. The malloc function is used to allocate the memory. Free is used to remove the memory. So we are remove the memory for this node. So next display function, we know that we can start from front portion to rear positions. So till temp of next not equal to null means the last node have the null pointer. So from the front portion, it will start to print it. Then it will point to the next node till it will be null. That's why we are using while loop. So finally, it will print this arrow mark with null. It will be printed there. Sample output I projected here. So I will give the options. Once you are choosing the options, accordingly the operation will be performed. I chosen option 1 for insert the elements. I insert 10, 20, 30. Then I call third option for display. It is like this. So in case I will give 2 means, it is the DQ operation, that is delete operation. It will delete it from 10, then 20, then 30. Like this it will be deleted. Then finally if I printed, there is null pointer is there, no element is there. So Q is empty will be printed. Again I call the display operation. So Q is empty is printed. So after completion of this presentation, that means now, so you are able to understand what is queue, what is linked list, what is linked queue, how to insert and delete the node in linked queue, and how to write the program for linked queue. So these are the things you know that. So because the outcome of this, after completion of this presentation, students will be able to represent queue using linked list. So I shared some questions for you, how it will be performed. So list the operations of linked list, linked queue, and then compare linked queue and linked list. Explain the procedure to insert a new node in linked queue. Write a C program for insert and delete node in a linked queue. We have any queries, you mail me. I will reply immediately. Thank you.